Hello, sir. My name is Siddhant, and my registration number is 19 BCE 1181, and I'll be giving my presentation for DA1 for our course Blockchain and Cryptocurrency Technologies, and my topic of presentation is Ethereum. So, basically, what is Ethereum? Ethereum is another blockchain similar to the one that we are studying, which is Bitcoin. So, Ethereum came on much later than Bitcoin, but right now it is the second most popular blockchain after Bitcoin. So let's talk a bit about the history of Ethereum. So Ethereum is a decentralized open source blockchain with smart contract functionality. Ether, also abbreviated as ETH, is the native cryptocurrency of the platform. Among cryptocurrencies, Ether is second only to Bitcoin in market capitalization. Ethereum was conceived in 2013 by the Canadian-Russian programmer Vitalik Buterin when he was of the age of 19. Additional founders of Ethereum included Gavin Wood, Charles Hoskinson, Anthony DiLorio, and Joseph Lubin. In 2014, development work began and was crowdfunded, and the network went live on 30 July 2015. Ethereum allows anyone to deploy permanent and immutable decentralized applications onto it with which users can interact. DeFi applications, which is also abbreviated as decentralized finance, applications provide a broad array of financial services without the need for typical financial intermediaries like brokerage exchanges or banks, such as allowing cryptocurrency users to borrow against their holdings or lend them out for interest. Ethereum also allows users to create and exchange NFTs, which are non fungible tokens, which are actually unique tokens representing ownership of an associated asset or privilege as recognized by any number of institutions. Additionally, many other cryptocurrencies utilize the ERC20 token standard on top of the Ethereum blockchain and have used the platform for initial coin offerings or ICO. We'll get to know about these specific topics as we progress into this lecture. And also, a series of upgrades called Ethereum 2.0 includes a transition to proof of stake, which is POS, and aims to increase transaction throughput using sharding. The main purpose of this upgrade is to increase transaction throughput for the network for the current rate of about 15 transactions per second to theoretically up to tens of thousands of transactions per second. This is to be accomplished by splitting up the workload into many blockchains running in parallel, referred to as sharding, and then having them all share a common consensus proof of stake blockchain, so that to maliciously tamper with any singular chain would require one to tamper with the common consensus, which would cost the attacker far more than they could gain from an attack. So let's go into the small structures of what Ethereum is built of. So Ethereum has two types of accounts. One is user accounts, also known as externally owned accounts, and the second type of accounts are called as contracts, basically smart contracts. So both the type of accounts can have a Ether balance. They may send or receive Ether. They may call public function of a contract or create a new contract, and are identified by the blockchain. So user accounts are the only type of account that may create transactions. For a transaction to be valid, it must be signed using the sending account's private key, 64 character hexadecimal string from which the account's address is verified. The algorithm to produce a signature is ECDSA, elliptical curve digital signature algorithm. Importantly, this algorithm allows only one to derive the signer's address from the signature without knowing the private key. Contracts are the only type of account that has associated code, which is basically a set of functions and variable declarations, and also contract storage. And contract function may take arguments and may have return values. In addition to control flow statements, the body of a function may include instructions to send it, read from, and write to the contract storage, create temporary storage that vanishes at the end of the function, perform arithmetic and hashing operations, call the contract's own functions, call public functions of other contracts, create new contracts, query information about the current transaction on the blockchain, and so on. It may perform a lot of operations. Next, we go to the concept of EVM, or basically the virtual machine which is maintained by the Ethereum blockchain. So, EVM is a runtime environment for transaction execution in Ethereum. It includes a stack, memory, gas balance, program counter, and the persistent storage for all accounts, including contract code. When a transaction calls a contract's function, the arguments in the call are added to the stack and the EVM translates the contract's bytecode into stack operations. Stack items may be stored in memory or storage, and the data from memory may be added to the stack. Gas is a unit of account within the EVM used in the calculation of a transaction fee. And each type of operation which may be performed at EVM is hard coded with a certain gas cost, which is intended to be roughly proportional to the number of resources, which is basically computation and storage. A node must be able to expend to perform that operation. When a sender creates a transaction, the sender must specify a gas limit and gas price. The gas limit is the maximum amount of gas the sender is willing to use in that transaction, and the gas price is the amount of ETH the sender wishes to pay to the miner per unit of gas used. So basically, in short, the creator of the transaction is trying to pay the validator who is validating that this transaction has been processed. So now let's talk a bit about ERC20 tokens. So ERC20 tokens, which is basically Ethereum request or comments number 20 token standard, allows for fungible tokens on the Ethereum blockchain. ERC20 tokens is just, in a simplified language, it is just a small set of rules that the coins have to follow and have to incorporate into their code. So the standard proposed by Fabian Vogelsteller in November 2015 implements an API for tokens within smart contracts. The standard provides functions that include the transfer of tokens from one account to another, getting the current token balance of an account, and getting the total supply of the token available on the network. Smart contracts that correctly implement ERC20 processes are called ERC20 tokens. They keep track of created tokens on Ethereum. Numerous cryptocurrencies have launched as ERC20 tokens and have been distributed through initial coin offerings or ICOs. Fees to send ERC20 tokens must be paid with Ether. Next, we come to NFTs or non fungible tokens. Ethereum also allows for the creation of unique and indivisible tokens called NFTs. Since tokens of this type are unique, they have been used to represent such things as collectibles, digital arts, sports, memorabilia, virtual real estate, items within games, and a lot more. The first NFT project, which was called as Ethereum, a 3D map of tradable and customizable hexagonal tiles, was deployed to the network in October 2015 and demonstrated live at DEF CON 1 in November 1 of that year. In 2021, Christie's sold a digital image with an NFT by Beeple for 69.3 million US dollars, making him the third most valuable living artist in terms of auction prices at the time. Although observers have noticed that both the buyer and seller had a vested interest in driving demand for the artist's work. Land, buildings, and avatars in blockchain based virtual worlds can also be bought and sold as NFTs, sometimes for hundreds of thousands of dollars. DeFi or decentralized finance is a use case of Ethereum It offers traditional financial instruments in a decentralized architecture outside of companies and governments' control, such as money market funds, which let users earn interest. Decentralized finance applications are typically accessed through a Web3 enabled browser extension or application, such as MetaMask, which allows users to directly interact with the Ethereum blockchain through a website. MetaMask can be installed into your browser as an extension, and you can create multiple extensions and multiple accounts, and you can use it as much as you want, in not only in Ethereum but also in EVM based chains also. So many of these D apps or decentralized apps that we use in this current world can connect and work together to create complex financial services. Examples of DeFi platforms include MakerDAO and Compound. Uniswap is a decentralized exchange for tokens on Ethereum, which grew from 20 million US dollars in liquidity to 2.9 billion USD in 2020. Like Compound, Uniswap, MakerDAO, all of these are given a human term which is called as protocols or DeFi protocols. And this is a completely different and very interesting topic, and also a topic on which I'm currently interning on at a different startup. So this is a very interesting topic, and someday we'll discuss about this also. So let's talk a bit about the internal working of Ethereum. Like Bitcoin uses SHA-256 or SJ-256, Ethereum uses a different variant called Kechek-256. It is very similar to SHA-3, and it won the contest for security in 2007, and it is used for all hashing in Ethereum. Derived differently from standard block cipher based hashes or previous SHA functions. The digital signatures that Ethereum uses, they are of same use case and cryptographic method ECDSA as BTC. Signers use a private key to generate a signed message. Signed message can be verified using the signer's public key. Hashes are signed in Ethereum, not the data itself. Very similar to Bitcoin as we have studied till now. So blockchain as a whole is a fully distributed database like Bitcoin. Highly secure, transparent and immutable. Nobody can change the data and everything is recorded on a public ledger. And it is very, very secure. But the disadvantages of blockchain, or rather or disadvantages of Web3, it cannot be scaled properly. And also the performance. And even though it is very unlikely to crash, because even if a lot of nodes crash, the other nodes will pull the system, but still, because whenever you try to pull the data, instead of pulling the data from a single server, all the data is pulled from various nodes, and that is why the performance and the scaling gets tampered with. So another concept of Ethereum is uncles or omers. Sometimes valid block solutions don't make main chain. Any broadcast block up to 6 previous blocks back with valid POW existence and difficulty can be included as an uncle block, and maximum of 2 can be included per block. So uncle block transactions are not included, just as headers, and these are aimed to decrease centralization and reward work. So basically, in layman term, what happens is, since it is based on POW right now, all the different nodes they compete for creating the node and pushing it to the consensus chain. And the first one who achieves it first, they put add their block to the main consensus chain. But the next ones, maybe the second or third rank, what they have to do, just to reward them and just to motivate them that they keep on mining for blocks, they are given a very small reward, and their blocks are also added to the blockchain, but not in the main list but in a parallel list, and these blocks are called as uncle blocks, and the transactions inside these are not actually included in the public ledger, but they stay inside that particular uncle block. And uncle headers can be included in main block for 1 by 32 of the main block's miners reward given to the said miner. Minor fungal blocks receive percent of main reward according to the given formula un plus closed 8 minus b of n into 5 by 8, where un and bn are uncle and block numbers respectively. So there's an example given, and we can see that. So the key differences are that blocks keep track of balances, not unspent transaction outputs like BTC, which is a major difference. Also, like BTC uses Merkle trees, Ethereum is a bit different. They tried to use a modified variation of Merkle Patricia trees, and they have three branches compared to Merkle trees two. Like, and also it is a very good move that Ethereum is going to make. They are going to transfer from POW to P of S or proof of stake with the use of Casper protocol. So we can see the details later. So yeah, Ethereum in the process of moving from POS to POS. This approach does not require large expenditures on computing and energy. Miners are now validators and post a deposit in an escrow account. The more escrow you post, the higher probability you will be chosen to nominate the next block. If you nominate a block with invalid transactions, you lose your escrow. One issue with this approach is that those that have the most Ethereum will be able to get even more. This leads to centralization eventually. On the other hand, it reduces the chance of a 51% attack and allows for near instant transaction approvals. This the protocol is called Casper, and this will be a hard fork. So basically, this will allow the rich to become richer, but this will make the system even more secure, and nobody can do civil attacks. And it will also increase the speed by a tremendous amount. So this will, in the long run, be a very good move, but the rich will become richer. That is a major issue of POS. So as we know, like Web3 or the whole concept of Web3 is an idea of new iteration on the World Wide Web, which incorporates concepts such as decentralization in the form of distributed ledgers, such as blockchain technologies, token-based economics, and a lot more. So, a very famous person had once tweeted that Web 1 was just for read, and Web 2 was a read-write based on read-write concept. But Web 3, the unique Web 3, is based on three things: read, write, and own. So using decentralization, we don't have to be a member of some organization to use the internet or to get various features. We'll be able to own our own things, our own tokens, our own virtual properties, and a lot more. So yeah, let's look a bit to the official documentation of Ethereum. So as you can see, Web 1 or Web 1.2, which was basically a read only concept, started in 1990 and lasted till 2004. It was a very backward version of our World Wide Web, and it was based on a read only concept. Then from 2004 till now, Web 2 is going on, and our whole world is revolving around Web 2. The apps that we use, like WhatsApp, the accounts that we create and browse through in Facebook, the shopping that we do on Amazon, the videos that we watch on YouTube, everything is part of Web 2, where we have the capability as a user to read and write information. And the Web 2 period began, especially with the emergence of social media platforms. Like instead of a read only version, the web evolved to read and write. When companies started providing content, users also began to provide platforms for users to share their own content and engage with other users, and it created a whole world of itself. And Web 2 also birthed the advertising driven revenue model. And after that came our much promised Web 3, and it was coined by Ethereum's co-founder Gavin Wood shortly after Ethereum launched in 2014. And like I told you, it mainly relies on using the concept of blockchain and cryptocurrencies and crypto technologies to let the users own a small part of the web. So, yeah, so the core ideas of Web3. Although it's challenging to provide a rigid definition of what Web3 is, a few core principle guides is its creation. Web3 is decentralized, it's permissionless, Web3 is native payments, Web3 is trustless, like basically what we have studied for BTC. So, and also like this is another concept called DAOs or decentralized autonomous organization, but we'll study it some other day. And yeah, so let's study a bit about what are contracts. So smart contracts was a concept that came into in the Ethereum blockchain. Bitcoin did not have this. It was a simple alpha coin. It was a simple cryptocurrency. And Ethereum introduced this concept like why only limit to cryptocurrencies? We can have our own code stored into the EVM. So whenever a contract is written and deployed, it consumes some ether to deploy it, and it gets stored into the EVM. And whenever it is called, the bytecode is converted into a usable function, and it is called like accordingly. So the problem with the traditional contract is that both the individuals who are signing the contract, like the both the signees need to trust each other to follow through each other to a stated outcome. So here comes smart contracts, which are digitized agreements which are based on by turning the terms on agreement into computer code that automatically execute when the contract terms are met. So you can't really modify it or stop it. It will, if it's set to happen, it will happen. And these are smart contracts which a user can't literally tamper with, and which is why people prefer this on Web3. Also, smart contracts are also useful for audits and tracking since it is based on a public ledger and it's a public blockchain. Anyone can instantly track asset transfers and other related information. You can check to see that someone sent money to your address, for example. And it also protects privacy because uh, since Ethereum is a pseudonymous network, and you can protect privacy from observers. Like because you never have to do a KYC or tell them who you are. You just have to create a unique address wallet and you can use that. So also, you can check out the code, which will mostly be written in Rust or Solidity or something else, and you can verify exactly what the code is supposed to happen, and everything will be visible to you. So it has a lot of use cases like stable coins like USDT and USDC. Then the gaming apps like decentralized gaming. Then creating and distributing digital assets, insurance policy that pays out automatically, and a lot more things. So so yeah, this was basically what Web3 is and what how Ethereum works. And Ethereum is a very cool concept. And since Ethereum was so popular, later lot of blockchains like Binance Smart Chain, Polygon, Avalanche, Phantom, and different blockchains came in. And these are blockchains which use Ethereum in their layer 2, and in the layer 1 they have their own computation and own logic. And these are all EVM based blockchain. And basically, what I mean to portray is that Ethereum changed the whole world. Ethereum changed the whole concept of introducing smart contracts into the blockchain, and that concept has done a tremendous job. And slowly, as Ethereum completely transfers to a POS system, Ethereum's speed will keep on improving and it will reach an ultimate high and much exponentially better than the current speed. And Web3 may become the future of in a lot of domains, specifically finance, because DeFi or decentralized finance is growing day by day. And I work in a DeFi based startup only. We are building a DApp of our own, a DeFi app. And the whole, since currency transfer is supposed to be simple, the code that is written for smart contracts for DeFi is very, very simple, so that the receiver and the sender, both of them, can understand that. And people are slowly moving from Web 2 to Web 3, where instead of transferring into real estate or stocks or mutual funds, they are trying to invest into protocols and ERC-20 tokens, and like IPOs. Blockchain Web3 has its own ICO, initial coin offering. Then also you can own virtual estate, you can buy and trade NFTs. Web3 is a whole world of its own, and it is growing exponentially day by day. And this is the future of our generation and of the world. Maybe later something new may come up and we may shift to